Have you ever worked on a project where adding just one small feature unexpectedly breaks something else, or changing the database suddenly requires changes across multiple layers? At the beginning, everything looks clean, but as the application grows, the code becomes difficult to maintain or difficult to test, and even small changes start taking much longer than expected. So, why this happen in so many software projects? More importantly, how can we build applications that remain clean, maintainable, and scalable as they grow? That's exactly what we are going to understand in this video. By the end of this video, you will understand not just what clean architecture is, but why it exists, what problems it solves, how it's structured, and how a request flows through the application. Today, we are not going to write any code. Instead, we will focus on understanding the concept first. Because once the concepts are clear, writing the code becomes much easier. And in part 2, we will build a complete clean architecture project in .NET in a step by step. Clean architecture helps us build applications that are maintainable, scalable, testable, and flexible. And these are the qualities every developer wants in their application. So if everyone wants applications that are maintainable, scalable, and testable, why do so many projects struggle as they grow? To answer that, let's first understand the limitation of entire architecture. Before we understand the solution, we first need to understand the problem. Most of us have worked with the entire architecture at some point in our careers. In fact, many enterprise application still uses this architecture today. So, is entire architecture wrong? Absolutely not. For small application or simple CRUD projects, it's a perfectly good architecture. It's easy to understand, quick to develop, and gets the job done. The real challenge begins when the application starts growing. Let's look at this typical entire architecture flow here. We have presentation layer, the business layer, the data access layer, and finally we have the database layer. At first sight, everything looks clean and well organized. Each layer has its own responsibility, but as the application grows, this layer becomes tightly connected, and that's where the real problems begin. Let's start with the first challenge, that is high coupling. Imagine your application is using SQL Server today. Tomorrow, your company decides to migrate some other database like PostgreSQL, or maybe you want to replace Entity Framework with a Dapper. Ideally, only data access layer should change. But in many entire applications, that single change starts affecting the business layer and sometimes even the presentation layer. One technology change ends up impacting multiple layers, and this makes the application harder to maintain and harder to change in the future. The second challenge is business logic slowly starts mixing with the infrastructure code. You will often find database queries, entity framework code, or the external API calls living right next to your business rules. After a few months, it's become difficult to answer one simple question: where is the actual business logic? When the business logic is scattered across the different layers, understanding the application becomes much more difficult. Now, let's talk about testing. Suppose you want to test a simple business rule, for example, checking whether the customer can place an order. Ideally, you should be able to test that logic independently. But in a tightly coupled application, that test may require a database configuration or even external services. Instead of testing just a business logic, you are forced to test the entire environment. And as a result, testing becomes slower, more complicated, and less reliable. As the application grows, maintenance also becomes difficult. A small feature request can require changes across multiple layers. A small bug fix may accidentally introduce another bug somewhere else. And when a new developer joins the project, it takes much longer to understand how everything is connected. Finally, the application becomes tightly coupled to specific technologies. Your business logic starts depending on the database, the ORM, or the external frameworks. But technology changes over time. Business rules usually don't. So, the real question is, how do we keep our business logic independent? from the databases, from the frameworks, and other external technologies. And that's exactly the problem clean architecture is designed to solve. So, let's understand what clean architecture is and how it solves these challenges. So, we have seen the problems with the entire architecture. Now, let's understand how clean architecture solves those problems. At a first sight, this architecture might look a little different. Instead of organizing the application into horizontal layers, clean architecture organizes it into concentric layers, where each layer has a clear responsibility. But the most important principle is this: dependencies always point inward. If you remember only one thing from today's video, remember this rule. Almost every design decision in a clean architecture follows this principle. The inner layers never depend on the outer layers. Instead, the outer layers depends on the inner layers. And this is the simple rule makes the application easier to maintain, easier to test, and much easier to evolve as requirements change. Let's start from the center. This is the domain layer. Think of it as a heart of the application. Everything that represents your core business belong here. This includes your entities, value objects, domain services, and the business rules that define how your application works. Notice what is not inside this layer. There is no database code, no entity framework, no web API, no external frameworks. The domain layer focuses only on the business, and that's what it makes it stable. Moving one layer outward, we have application layer. This layer contains the application's use cases. In a simple words, it defines what the application should do. It coordinates the flow of the application, validates requests, executes business operations, and communicates with the domain layer. One important thing to notice is it doesn't directly talk to the database. Instead, it works with the interfaces. And that's why the application doesn't depend on a specific implementation. Now, let's move to the infrastructure layer. This layer contains all technical implementations. For example, database access, repository implementation, external APIs, email services, file storages, or any third party integrations. Here is the important part. The infrastructure layer depends on the application layer, not the other way around. That means if tomorrow you replace SQL Server with the PostgreSQL or replace Entity Framework with the Dapper, most of your application remains unchanged. Only the implementation changes, and that's one the biggest strength of clean architecture. Finally, we have presentation layer. This is the layer user interacts with. It could be an ASP.NET Core Web API, an MVC application, a Blazor application, or even a mobile application. Its responsibilities are simple: receive the request, pass it to the application layer, and return to the response. It doesn't contain business rules. It simply acts as the entry point into the application. So, if we stay back and look at the complete picture, each layer has one clear responsibility. The business logic stays at the center, the technology stays on the outside, and because of that, our application becomes more maintainable, more testable, and more scalable, and much easier to adapt when technology change. Now, what we understand the architecture, the next question is how do we organize all these layers inside the real .NET solution? Let's look at the next. When developers first hear about the clean architecture, one of the most things they notice is multiple projects. It might even feel like too many projects, but the goal of the clean architecture is not to increase the number of projects. The real goal is to create clear boundaries between different responsibilities. When each project has a single responsibility, the application becomes much easier to understand, maintain, and extend. So let's look at the project one by one. At the center, we have a domain project. Think of this as a heart of your application. This project contains your business entities, business rule, value objects, domain events, and everything related to your core business. Notice what is not there. There is no entity framework, no SQL Server, no ASP.NET Core, no external frameworks. This project focuses only on the core business. Next, we have the application project. This project defines what the application should do. Here you will typically find commands, queries, handlers, data transfer objects, the DTOs, interfaces, validators, and the application services. One important thing to remember, this project doesn't know how data is stored. It simply defines the contracts and coordinates the application's business flow. And in a part 2 of this series, this is where we will implement CQRS and Mediator. Moving on, we have the infrastructure project. This is where all technical implementation live. For example, entity framework, repository implementation, authentication, email services, logging, file storages, or any other third-party integrations. This project implements the interfaces defined in the application project. That's what keeps our business logic independent from the technology. And finally, we have presentation project. This is the entry point of our application. It could be an ASP.NET Core Web API, an MVC application, or a Blazor application, or even a mobile application. Its responsibilities are simple: receive the request, pass it to the application layer, and return the response. It should never contain the business logic. You will also notice a separate test project. This is where we write unit tests, integration tests, and other automated tests. Keeping tests separate makes the solution cleaner and help us verify the business logic without affecting the main application. If we step back and look at the complete solution, you will notice something interesting. Every project has one clear responsibility. Business logic stays in the domain, application flow stays in the application project, technical implementation stays in the infrastructure, and the API or UI stays in the presentation project. This separation makes the application much easier to understand, easier to maintain, and much easier to scale as a new feature are added. Now that's we have seen how the solution is organized. Let's see something even more interesting. What actually happens when the request comes into our application? Let's follow that request from the controller to all the way to the database and back. So far, we have understood the problems with the entire architecture, how clean architecture solves the problems, and how we organize the solution into different projects. Now, let's see how the request actually flows through the clean architecture application. Everything starts with the client. The client could be a web application, a mobile application, or even another API. The client sends the request to our ASP.NET Core Web API. The request first reaches to the controller. In a clean architecture, the controller should remain very thin. Its responsibility is simply to receive the request, perform the basic input validation if required, and pass the request to the application layer. It should never contain any business logic. From the controller, the request moves to the application layer, and this is where the application use case is executed. If you are following CQRS, this is where command or the query handler process the request. The application layer coordinates the entire business flow. If the business rule needs to be applied, it works with the domain layer, and if the data needs to be stored or the retrieved, it works through the interfaces. The domain layer contains the core business rules. This is where the application decides where the operation is valid, what business constraints should be enforced, and how the business behaves. Remember, this layer doesn't know anything about the database, entity framework, or any external frameworks. It only knows the business. Now, suppose the application needs the data. The application layer doesn't directly access the database. Instead, it calls the interfaces. And the actual implementation of that interfaces lives inside the infrastructure layer. This layer communicates with the database, external APIs, email services, file storages, or any other external systems. This is one of the biggest advantage of clean architecture. The application layer doesn't know how the work is done. It only knows which contract it needs, and that keeps the application loosely coupled. Finally, the infrastructure layer interacts with the database. The required data is retrieved or saved, and the response begins just journey back. The response travels back through the same path, like database, infrastructure, application, controller, and finally back to the client. Each layer performs one clear responsibility and then passes to result to the next layer. If you look at the complete flow, you will notice one important thing: the business logic always stays at the center of the application. The database, frameworks, and external technologies remain on the outside. Because of that, our application becomes easier to maintain, easier to test, and easier to extend, and much more flexible when technologies change. And that's the real idea behind clean architecture. It's not about creating more projects or adding more layers. It's about creating clean boundaries, protecting your business logic, and building applications that can grow without becoming difficult to maintain. And that's a wrap up for part one. Let's quickly recap what we learned today. We started by understanding why clean architecture is needed and the common challenges we face as applications grow. Then we looked at the limitations of entire architecture, such as high coupling, mixed business logic, difficulty in testing, and technology dependency. After that, we understood the core principle of clean architecture, where dependencies always point inward, keeping our business logic independent from external technologies. We also explored how a clean architecture solution is organized into different projects. And finally, we followed a complete request flow from the client all the way database and back. I hope this video has helped you understand not just what clean architecture is, but more importantly, why it exists. And in a part 2, we will take everything what we have learned today and build a real .NET application from scratch. We will implement CQRS, mediate R, dependency injection, entity framework, and understand how all these pieces work together in a real application. If you found this video helpful, please consider liking the video and subscribing to Pattern Forge. If you have any questions or topics you would like to me cover in a future videos, let me know in the comments. Thank you so much for watching. Keep learning, keep building, and as always, build intelligent solutions. I will see you in the next video. Thank you so much.